Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. In this video we will discuss LNK564 IC. It is a flyback offline switcher for low power application. It is used in flyback 1 watt, 1.5 watt, 2.5 watt, 3 watt applications. So it is very useful switcher. It does not use any excessive components. So with minimum components we can design a very compact design with universal power supply. This is a reference design for this IC. It is about 2.5 watts, 12 volt, 200 milliampere design. It have 90 volt to 265 volt AC. It have a wide range of input voltage. Then it have 2.5 watt, 10 ohm resistor. We can say it is used as a surge protector. It is working as a fuse because it is fusible resistor. Then it have a bridge rectifier, that is 1N4007, 4 diodes, or we can use a bridge rectifier pack. Then it have a first stage bulk capacitor, that is C1, 4.7 microfarad. It have a RL filter, 1 millihenry and 2.2k resistor. Then it have a second stage bulk capacitor. Here this IC is used. It is LNK564PN. So this IC does not have any biasing component, any VCC, startup resistor, or any RTCT components. So it is used in CC, constant current mode, and constant voltage mode. Here it have a snubber circuit, 1N4007, 1 nanofarad 1 kilovolt capacitor, and 500 kilo ohm resistor. Transformer is here. If you want to design the transformer with EE16 ferrite core, gapped core, 120 turns for 1 millimeter, 29 turns 1 millimeter, 14 turns 1 mm, 3 wires, triple insulated wire. When we apply voltage, it will charge internally through its 5.8 volt internal regulator, because it does not have any external charging circuit, external startup circuit. So it will receive voltage from this winding, positive voltage from here, and it will charge this bypass capacitor. That is outside. We can say it is working as a VCC capacitor. It is 100 nanofarad 50 volt capacitor. When it will receive voltage at 5.8 volt, this IC will start switching. When it will start switching, so this IC 564, it is working at 100 kilohertz. If we are using 562 LNK562, that is 66 kilohertz. If we are using LNK563, that is 83 kilohertz. In case of LNK564, that is 100 kilohertz. So it will start switching at 100 kilohertz. We can say it will switch this ground line to the transformer, because transformer have positive voltage. So it will switch the pulses here. It will switch on, switch off between ground and the transformer winding for, we can say, 100,000 times in 1 second. So this changing voltage, switching on, switching off, switching on, switching off, will vary the magnetic field here in primary. So it will cause to induce voltage in the secondary. We will find voltage in secondary. Meantime, we will also receive voltage in this winding. So this will produce a feedback voltage through this resistor network, 47 kilo ohm and 3 kilo ohm resistor. So it does not use any optocoupler, any adjustable Zener regulator, any feedback network. So it is using this auxiliary voltage as a feedback voltage, and our output will follow the same feedback voltage because it is monitoring this auxiliary voltage. So if we find that the voltage are present here and this snubber circuit is working and this IC is not working, in that case this IC is bad. We have to replace it. Pin number 1, 2, 7, 8 are source pin. These are the ground pins. Pin 3 is bypass pin. Pin 4, that is feedback pin. Pin 5, that is drain pin. So drain pin is connected between the positive voltage and the primary winding. So this source pin, it is connected to ground. These source pins, these are connected to ground. So this IC will cause to switch this ground voltage, positive capacitor voltage, so it will cause to switch this ground through internal MOSFET from here, from source to drain. At drain we connected our transformer here. When it will receive feedback, it will keep switching. Anytime the feedback voltage will drop less than 4.8 volts for 100 milliseconds, so this IC will go in reboot mode. That means either the output circuit is overloaded or due to any reason, if the voltage are dropped, it will start to fluctuate. We have to check this circuit or the output circuit. If we cannot find this IC, then we can use NCP 1010, NCP 1011, NCP 1012, 1013 or NCP 1014. This IC is normally in P101, P1010, P1011, P1013. We can use this IC, but we have to use this IC with the suffix that is 100, 1011-100, so that will 100 kilohertz. Because every IC 1010, it is also 65 kilohertz, 100 kilohertz, 130 kilohertz. 1011, that is 65, 100, 130. 1012, 65, 100, 130 in different power ratings. So we have to select -100, and then we have to make some changing. We have to alter the pins. In 564, pin 1 and pin 2 is ground pin. Here pin 2 and pin 3 not connected. Pin 1 is VCC, and here pin 3 is bypass. If you want to connect in this place, at that time we have to disconnect the ground pin from pin 1 and 2. We have to disconnect the track, and then we have to connect this number 3 pin to the VCC pin, because in this format pin 3 is not connected. We have to disconnect track from the PCB, and we have to make jumper beat for this IC. When we will make jumper, so in that case the bypass pin will be considered as a VCC pin. So this IC will work in this place. You can replace and you can turn on your circuit, or you have to find the same number. It is the best solution. I hope so this video is informative. If it is informative, hit the like button. If you have any question, please let me know in the comment box. Thanks for watching. Assalamu alaikum warahmatullahi wabarakatuh.